TransFizz, Integrated Distant and Close Reading of Othello Translations. TransFizz is a design study that we propose to integrate close and distant reading of multiple translations. It's an interactive tool that is designed with close collaboration with a domain expert in translation studies to deliver a novel design that is capable of exploring and analyzing the interrelationships between translations. The design is guided by the visual information seeking mantra to provide an overview first, zoom in into the segments level, and then provide details on demand. 5 tasks that are identified based on the typology of visualization tasks by Bremer and Monsner in order to action 6 requirements. TransVis contributes the following: a novel visual design that supports comparison of multiple parallel translations, customized mechanisms for rapid and interactive filtering and selection of a large number of German translations of Shakespeare, interactive and dynamic analysis of similarity metrics to support comparisons and analysis of customized parallel translations, examples, detailed observations, a case study, and domain expert feedback from a specialist in German translations of Shakespeare. We divide the previous work into mainly 3 groups. Visual comparison of general text, which includes designs that support the analysis and visualization of a single or more unrelated texts. Visual comparison of parallel texts, which includes designs that support the analysis and visualization of related texts, such as editions or translations. Previous work on Shakespeare's Othello, which includes designs that analyze and visualize Othello German translations. We summarize the previous work that study related texts in Table 1 in the paper. A group from the arts and the humanities working on a project called Translation Arrays, Version Variation Visualization collected 55 translations of Shakespeare's play Othello. The translations span 1766 until 2010. So far, 38 translations of the collection were optically scanned from paper prints, corrected from OCR errors, segmented and aligned with the English-based text to create a parallel corpus. The translations were collected over a time span of 2 to 3 years from various sources such as libraries, second-hand booksellers, archives, theater publishers, and theater companies. The translation data is stored in XML format on the project's website. The ED and VIV metrics was introduced by Cheesman et al. To quantify how a given base segment is interpreted and translated between parallel texts. ED characterizes the translated segments in terms of distinctiveness. A higher ED value indicates higher dissimilarities from other translations. VIV, on the other hand, is the average pairwise distance between every 2 segments projected on the base segment. VIV represents the stability of the base segment. A high VIV value indicates low stability, which means the segment's translations vary considerably between authors. Along with the domain expert, we established and incrementally refined a list of requirements: an application that enables comparison of translated parallel text, a visual design that supports both close and distant reading, a layout that supports close reading for further detailed analysis, a visual design that considers stable versus unstable translations, interaction that enables customization of the translated text, interaction that supports general exploration and analysis. Based on the requirements and the typology of visualization tasks, we established these 5 tasks. In the discovery process, the user should be enabled to explore the alignment overview in order to identify a region of interest. After identifying a region of interest, the user may navigate the space leveraging smooth zooming and panning. As the user navigates, multiple levels of details are aggregated and rendered. As the user performs task 1 and/or task 2, the user may apply different filtering and selection tasks to assess the exploration task. As the user performs task 2, the user may select a segment to obtain details on demand. As the user performs task 1, task 2, and/or task 4, the user may perform interactive comparisons of the parallel translations, exploiting metadata based on the alignment of speeches and text similarity metrics. Our design is composed of four main components that aligns with the visualization information seeking mantra: an alignment overview, an option panel that provides interaction and exploration means to the alignment overview, the detailed view, and the term level comparisons view, TLC. The alignment overview presents a parallel view of translations, and in each translation it presents the encapsulated structure. It provides distant reading and a general context for understanding the collection and conveys the whole dataset in one visual layout. The alignment overview leverages interactive capabilities to enable the user to explore and find interesting patterns and features within the collection. It enables users to examine significant larger patterns in the translations which are not readily viewable from a narrow or detailed view. Each parallel line shows a translation, and each rectangle represents a segment. We incorporate ED and VIV analysis to detect variation among translations. Each segment within an alignment path is assigned an ED value, and each path is assigned a VIV value, which is projected on the English segment. The user can drag and drop a translation to change the order of translations. When zooming, the user can reveal the text and obtain close reading of the collection. The Options panel incorporates exploration and interaction means to customize, change, or edit the alignment overview. It facilitates an interactive searching mechanism. From the Options panel, the color schemes can be changed. Also, the mapping can be changed to segment length, speech length, or to ED and VIV values. The user can change the order of the translations based on different sorting options. The user can enable or disable the option of interactively aligning the translation vertically when selecting a segment. The user can filter the collection to show specific speaker segments. Also can add or remove stage direction segments. From the time-oriented thumbnail view, the user can customize the collection by adding and removing translations. The third main component is the detailed view, which is the focus subset that the user is interested in after performing filtering and selections in the alignment overview. The detailed view shows a close reading of the user selected speech along with the aligned translations. It stores both the aligned segments and the alignment overview state, so the user is able to revisit any previously selected paths for further analysis. Also, the text in this view is accessible to the user and can be copied to be used beyond the tool. The TLC view visualizes all of the vocabulary used in ED and VIV. Each parallel line depicts a translation, and each polyline represents a word. The word value for each translation indicates the term weighting that contributed to ED analysis. The TLC view incorporates a word list accompanying the timeline graph. The user selects an interesting alignment path and drag and drop to generate the TLC view. The user can choose a word from the list and the corresponding polyline will be highlighted. Also, the user can select polylines from the timeline and the corresponding words will be highlighted. The design was evaluated through domain expert feedback sessions. We conducted 9 in-person sessions over 5 months. All of the sessions are video recorded for post-analysis. Transfizz is also evaluated using case studies to address 2 questions. Do apparently identical texts differ? Discovering the work of editors and writers. Do translators differ? The individual distinctiveness of translators. We see an example of translation variation between 5 editions of Bautzen, 1832. On the left, Wolf's translation stands out due to the high values of ED. After deselecting the Wolf's translation on the right, we can see more variation among the 4 remaining translations. The domain expert states, this reveals that the 1926 so-called edition, revised by Max Wolf, is not really an edition of the Bautzen translation at all. It's almost a completely new translation created by editing Bautzen. For the emerged variation after the deselection of Max Wolf's translation, the domain expert states, some of this variation is due to historical spelling changes. Some changes are more significant. They are caused by editors aiming to improve the Gaussian text they have received, making it easier for readers, actors, and audiences. The domain expert explores variation between these translations at the term level using the TLC view, with the segment starting with the AIM reports. The domain expert states the segment was translated by Gaussian as conjecture reports, 1851. This is a very compressed expression, meaning people making conjectures report. Not easy to follow and also difficult to speak. Some later editors changed this to estimating people report, 1923. Supposition reports, 1947. Rumors report, 2000. The TLC view shows this clearly when examining the summits of the translation's dimensions. During the domain expert feedback sessions, different observations were discovered. For example, in a speech Iago says, "If thou dost, I shall never love thee after." All other Gaussian translations use the word Freundschaft, which means friendship, except the 1926 edition uses the word Liebe, which means love. The domain expert justifies, again, intensifying and bringing back the hint of homoeroticism in the original, which the classic text censored. Another example that was discovered during the feedback session by a non-German speaker and then justified by the domain expert, that there are 3 translations that stand out from the rest. The 3 translations have 3 recognizable words with high values which can be easily noticed in the TLC view. These words are different translations of the English word moor in the context "I hate the moor." The domain expert validates the discovery and reasons that the word is translated in different ways in different times with different political implications. More examples of use cases and observations can be found in the paper. A full demonstration of TransVis features can be found on the TVCG YouTube channel. Future work. We are looking forward to applying TransVis to other translation corpora. Incorporate semantic clustering and structural similarity between translations. The rendering could be updated to reflect this when zooming in or out of the scene. Scalability is a challenging issue when dealing with large parallel text, and more in-depth research to address this is encouraged. Thanks for watching.